Hey guys, in this video I'm going to show you how to answer the Maths Method Sample Exam 2 External Response Question number 1. Reading the question, we've got the population of wombats in a particular location varies according to the rule n of t, where n is the number of wombats and t is the number of months after 1st of March 2013. Part A. Find the period and the amplitude of the function n. The function n is a cos function, and so its period is going to be 2 pi on n, where n is the coefficient of the t term. And so the period is going to be 2 pi over pi on 3, which is going to be 2 pi over 1 times 3 on pi. The pi's will cancel out, and so the period is going to be 6. The amplitude is going to be the constant that's in front of the cos function, and this is 400. And so therefore, the amplitude is going to be 400. Part B. Find the maximum and minimum populations of wombats in this location. The range of a cos function, we know, is found by the mean position minus the amplitude, which is its lowest value, and its mean position plus the amplitude, which is its largest value. And so the minimum population is going to be the mean position, which is the constant that's added to the cos function, minus the amplitude, which is 400. And so this is going to be 800. For the maximum population, this is going to be the mean position, which is 1200, plus the amplitude, which is 400, and so this is going to be 1600. Part C. Find n of 10. To find n of 10, we can use the calculator. First, we'll need to define the function. And so, using the calculator, it's going to be best to define this as n of x, as we need to sketch its graph later on. And now to work out n of 10, this is equal to 1000. Part D. Over the 12 months from 1st of March 2013, find the fraction of time when the population of wombats in this location was less than n of 10. We just worked out that n of 10 is equal to 1000. To find the times when the population is going to be less than n of 10, which is less than 1000, we first need to work out at which times the population is going to equal 1000. To do this, we can use the solve command in the calculator. And we let n of x equal 1000. And we solve for x. Now, because we're solving a trig function, we also need to specify the domain. Otherwise, we're going to get a general solution. And so we want x to be values between 0 and 12. And so when t is equal to 2, 4, 8, and 10, the population of the wombats is going to equal 1000. From here, it's best to look at the graph of n of t and the line n of t is equal to 1000 to see the behavior of the wombat population. And so, graphing n of t, or n of x, we're going to need to change the window settings to get a better view of the graph. We know that the minimum value was 800 and the maximum value was 1600, and we want the x values to be between 0 and 12. And so choosing an appropriate setting, we now have a better view of the graph. And now if we draw the line n of t is equal to 1000, we can see that the population, which is the blue graph, is going to be less than 1000 when t is from 2 to 4, which is 2 out of 12 months, and then from 8 to 10, which is another 2 out of 12 months. And so therefore we can say that the fraction of time where the population is going to be less than 1000 is going to be 2 out of 12 plus 2 out of 12, which is equal to 4 out of 12, and this is simplified to be 1 on 3. And that's it for this question. Now, if you guys want to learn or practice more exam-style questions related to trig applications, then you can do this easily by logging into the Maths Methods Club. And from the main topic, select Functions and Graphs. And then from the subtopic, select trigonometric or circular functions. And if you want to practice extended response questions, go to question type and select extended response. Here, you're going to find all the past exam questions related to trig applications. Go through these questions, that way you're going to be better prepared for your SACS and exams when it comes to answering trig applications. And if you get stuck, just watch the solutions. Thanks for watching, good luck, and I'll see you guys in the next video.